Question 5, Part A, Part 1. How does the electric current in a metal differ from that in an electrolyte? Compare each with conventional current for 4 marks. Well, you can say that the electric current in a metal differs from that in an electrolyte in that the current in a metal is carried by electrons only. Meanwhile, the current in an electrolyte is carried by both electrons and protons. That is, in other words, in a metal, there are only negative charge carriers. But an electrolyte, there are both negative and positive charge carriers. Now, conventional current is when the current moves from the positive terminal to the negative terminal using positive charge carriers. So, comparing them, you can say that the current in a metal is opposite to conventional current. But the current in an electrolyte may be the same as conventional current, and it could also be the opposite. Part 2 of Part A. State which of these two media, metal and electrolyte, has similar current flow to that in a semiconductor. Give a reason for your answer. Well, an electrolyte has similar current flow to that in a semiconductor because a semiconductor has both positive and negative charge carriers, similar to that of an electrolyte. Part B. The makers of a popular cell phone have upgraded its battery capacity from 4,320 coulombs to 9,000 coulombs. If the standard charger can deliver a current of 0.6 amperes, how much more time will it take to charge a new battery than the old battery? So we have our formula. Time is equals to charge divided by current. T is equals to Q over I. We'll do it similarly for the new battery and for the old battery. So the new battery has a capacity of 9,000 coulombs. If we divide that by the current of 0.6 amperes, we'll get 15,000 seconds. Meanwhile, the old battery, its capacity was 4,320 coulombs. Dividing that by 0.6 amperes, you get 7,200 seconds. So how much longer will it take? Well, the change in time will be the difference between them. So 15,000 minus 7,200 gives you 7,800 seconds. Converted to minutes, dividing by 60, that would be 130 minutes. Converting to hours and minutes, dividing by 60, that would be 2 hours and 10 minutes. Part 2 of Part B. In order to maintain a competitive edge, the cell phone maker needs to keep the same charging time for the new model the same as the old model. What must be the current rating on a new charger to accomplish this? So, the new charge total is 9,000 coulombs, but the old time that it took to charge was 7,200 seconds. So you want the current for that new charge with the same old time. So current is equals to charge divided by time, I equals Q over T. So it's going to be 9,000 coulombs divided by 7,200 seconds, which gives you a current rating of 1.25 amperes.